All right, so what if you were to encounter this problem where someone asks you to figure out the derivative of a function that is the product of two other functions? Remember that the word product just means the result of multiplying. So there we are, x squared times sine of x. Well, what is that going to be? Let me show you the most common mistake on this subject. Well, I know how to do the derivative of x squared. This one is 2x. I just learned the derivative of sine. I heard that that's cosine. So should I just multiply those together? No. No, this is incorrect. So despite the fact that this does work for limits, by that I mean we do have a rule that says the limit of the product of the two functions is the limit of the first one just times the limit of the second one. Despite the fact that it works for limits, it doesn't work for derivatives. So this video is about how do you actually take the derivative of a product of two functions? Let's learn. So the rule we want is called the product rule, and it can be written in a few different ways. I've written it here in three different ways with three different types of notation. My favorite is the Euler notation. I know it looks kind of long that way, but I do like it. The shortest way to write it would be with the Newton notation. And in this case, the way I wrote it with Newton, I'm even omitting the arguments. So I'm omitting like of x from all of the functions and just showing how it works. And then with the Leibniz notation, instead of calling the functions f and g, with the Leibniz notation, it tends to work better to use variable names like x and y. In this case, for the two functions, I'm using the letters u and v. So it's just those are when you have two functions and you're working with them as variables, you often use u and v. You'll find that happens later in the semester as well. So anyway, the picture here is when you are trying to take a derivative of the product, you need to focus on each function one at a time. And what you'll see here is instead of f prime times g prime, where you're trying to do the product of the derivative of each function and just multiply the results together. No. You just do the derivative of one at a time. So here's the derivative of f multiplied by g, and this g is just the original g function that you started with. It's not the derivative. And then and then you add a second term, and in that case you leave f alone and you just do the derivative of g. It can be helpful to see the pattern. I think it can be helpful to see how it extends. If you had three functions multiplied together, f times g times h, and you wanted to take the derivative of a product of three functions, what you would do is you would take the derivative of one function at a time. You'd say, let's take the derivative of f and multiply that by g and by h, and then add another term. And then you'd say, this time I'm going to leave f alone. I'm going to take the derivative of g, and I'm going to leave h alone. And then you would add another term, f alone, g left alone, and this time I'm going to take the derivative of h. So in each case, there is one of the three functions that you're differentiating, but only one. And I bet now you'll be able to figure out what it looks like if you want to take the derivative of four functions. Let's call the next one k. Try that on your own, just as an exercise to see if you can extend the pattern. This is how derivatives of products work. So let's apply this to our original example. It was x squared times sine of x. I'm going to copy that down below. Let's do it correctly this time. Y equals x squared times sine of x. To take the derivative of this correctly, y prime, we'll have two terms, term 1 plus term 2. And in term 1, we'll take the derivative of the first factor, x squared. So that'll be 2x. But that will just be multiplied by the original second factor, sine of x. In the second term, we'll leave the x squared alone, and we'll just take the derivative of the second factor. The derivative of sine is cosine. So it looks like that. And there we go. That's the result. It's 2x times sine of x plus x squared times cosine of x. That's following this product rule pattern described up there. So, okay, having presented it, introduced it, told you that this is a mistake, and showed you down here, I guess just this part, and showed you down here the correct way to do it. Now, what I would like to do in this video is see if I can explain why the product rule is what it is. I'm going to pause for a moment and draw a picture. So here we have a rectangle, and I'm going to imagine that the dimensions of this rectangle, its width and its length, are each like corresponding to the value of the functions f and g. So have f represented here as this length, and g is, that width. So if you multiply f of x times g of x to create a new function, that new function can be interpreted as the area of this rectangle. So here in the area, the shaded area, I have f times g. The resulting function, product of those functions, is a function of x, and it gives us this area. So now what if I were to change x by a little bit? Change x, and we have a delta x, okay? Let's say we add on x a little bit. Let's say when we add on a little bit to x, that is going to have the effect of adding on a little bit to f of x. So this is going to be like delta f, the change in f that results from changing x. And then we're also going to add on a little bit to g. Sorry, my screen's got to see here. So then there we go. Let's say we add on a little bit g. That's delta g. So this change in x causes delta g, and it causes delta f. Okay, but now what's the overall change in the area? Well, I can go like this and like this. And this here is the overall change in the area, and it's the overall change in the product function, f times g. So that whole thing is delta f times g. Now, the derivative is going to be that divided by delta x, right? And to see exactly how we can interpret that in terms of the f and the g individually, we can break it up like this. And see, this is delta f times g, delta f times g, whereas this is f times delta g, f times delta g. And this is delta f times delta g, like that. So when I say, when we want to know the derivative of f times g, like that, we would be talking about the limit as delta x approaches 0 of delta fg divided by delta x. But our delta fg can be broken up into these parts. It's going to be delta f times g plus f times delta g. Actually, let me write those in the other. Let me write those in the other order. F times delta g plus g times delta f, or maybe like that. I'm trying to write it in a way that makes it very similar to the product. And then plus delta f times delta g. And all of that's divided by delta x. And you can kind of imagine how, after a few steps, I'm going to skip over some of the details here. You can kind of imagine how we're going to arrive at something like f times the limit of delta g over delta x plus the limit of delta f over delta x, but then just times g, and then plus 0. The last part, I'll wave my hands around this and not give you a particularly satisfying explanation. That last part, that part ends up being negligible. Basically, as the delta x gets smaller, that's going to get smaller, that's going to get smaller. This part and this part are going to matter, but this part doesn't matter. It's too small. It turns out not to. So that's kind of the general idea, is that last little bit, that little corner there, that goes to 0. And then you can see how this ends up being f times g prime plus f prime times g. Oh, and I did write it backwards. I was trying to write it in the same order, and I ended up writing it in the opposite order. No big deal. That's okay. But there you go. So that sort of gives you a vague idea of like how the product rule actually, like why the product rule is what it is. This is by no means a formal proof. There is a formal proof, and it's complicated and messy, and it's not really worth our time to go through together. But I did want to show you this much because I like that picture. I think it gives you kind of a clear, a pretty clear idea of where this could come from. And it's a nice way to remember f prime times g plus f times g prime. We'll visualize it. This part plus this. All right. So that's the product rule.